Ladies and gentlemen, I'm Konstantin Scho, the International Product Manager for the Vortex Flow Meter series of Endress+Hauser called Prowirl. Prowirl is a worldwide leading vortex product and has been successfully used in more than 300,000 applications, enabling the accurate and reliable flow measurement of liquid, gas and especially steam. In steam applications, Prowirl 200 is used to measure mass and energy. One of the main benefits of the Prowirl line of flow meters is that it is optionally able to detect low steam quality, resulting, for example, from the priming of boilers, or even measure the dryness fraction, which is an important quality parameter of steam. Wet steam is both a safety and an efficiency concern in the process industry.
If the boiler is undersized for the application, or too many users are using steam at once, this leads to reduced pressure in the boiler. This again leads to more turbulence and therefore more potential for water to be carried over, which is commonly known as priming.
Potentially, this may provoke boiler shutdowns. In this graph, we can see an application where the boiler was undersized for the application. We can see that 10 shutdowns were generated within 1 hour caused by a demand that was too high for the boiler's design load. Another potential reason for priming is a too high content of total dissolved solids in the boiler water.
This may be caused by poor makeup of the feed water or poor blowdown of the boiler. Again, this will result in more foam forming inside the boiler, which may at the end of the day lead to a boiler shutdown.
In all these scenarios, water is carried over into the steam system. This may lead to water hammer, corrosion of steam equipment and piping, and of course will reduce the efficiency. If the boiler is operated properly, wet steam can also form due to heat losses anywhere in the steam distribution system.
If the boiler is operated properly, wet steam can also form due to heat losses anywhere in the steam distribution system. Heat losses can occur either in the steam piping because of poor insulation or at the point of end use due to malfunctioning equipment. An improperly functioning steam trap is one example. This may lead to inundated heat exchangers, which may cause water hammer again and reduced steam quantity upstream of this equipment.
As mentioned before, wet steam is not only a safety issue. For example, if wet steam is used for heat transfer, you decrease the efficiency of your system quite dramatically. If steam has only a dryness fraction of 90%, the energy available is reduced to 90%. In the end, it will reduce your earnings. Wet steam can occur anywhere between the boiler and the point of end use. This is both a safety and an efficiency concern. Even though this parameter is obviously quite important, this parameter is usually never measured because there has been no affordable solution available. As one of our customers stresses, everybody would like to know about the dryness fraction, but nobody really knows it. Endress+Hauser has therefore decided to invest in the research of wet steam. We built a steam rig that allows us to generate wet steam in 3 different ways. By injecting channel flow directly into the pipe, by injecting water through a nozzle, or by cooling down a section of the pipework. During this basic research, we found out that it didn't matter how we injected the wet portion. The flow pattern further downstream was always the same. First, a small channel forms. When the dryness fraction is reduced further, this channel smears up the pipe walls until they are completely covered, reaching a state of so-called annular flow. Investigating further, we found out that the reduced dryness fraction had an effect on the primary signal of the vortex meter. A signal parameter called kurtosis was affected. By checking this parameter, the new Prowirl F200 is able to generate an alarm when a dryness fraction of 80% or below had been reached. This is the world's first integrated wet steam alarm in a vortex flow meter. In a next step, we further investigated the kurtosis parameter. We found out, by analyzing this parameter, that the dryness fraction of the steam can be directly determined based upon the research we did. After determining the steam quality, we can even correct the meter's mass and energy outputs by correcting the condensate. This is extremely important because condensate contains way less energy than the steam itself. All these energy calculations have been done according to the worldwide accepted standard IAPWS IF97. By adding a qualitative parameter to a quantitative measurement, the Prowirl F200 is the revolution in vortex technology. With the innovations we have seen in this video, the detection of wet steam and the measurement of the dryness fraction of the steam, the Prowirl F200 will help our customers to improve their efficiency and increase the safety of their steam systems. Thank you for your attention.